Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look again at the creation of game utilities with our game map by adding a zoom window. This was our application at the end of the last video. The dialog we see on screen here allows us to select a world map. Having selected a world map, it's displayed on the large graphics control. We can then attempt to process a turn, which positions 50 rulers on the map. Once we hit the bulk turns, it will then process 100 turns and allow each of the rulers to move around the map and start to gain territory. This gives you an indication of the size of each of the little empires that the rulers are creating. What we're going to do today is a zoom in on the main graphics map. If we move our mouse over one of the territories, or perhaps one of the rulers, and left click on the mouse, we get a pop-up window. This pop-up window shows us the X and Y coordinates of the terrain. It also shows us the owner's number and some details about the owner. This owner is currently active and they have control of 38 of the territories on the map. So what we're going to look at now is how we achieved the clicking on the graphics control and the determination of which terrain we were actually clicking on. So let's have a look at the code. If we have a look at the callback function, the event handler of the main dialog. In here is the code that handle each of the events that occur on the main dialog. We're specifically looking at the graph territories graphics control. Here we're picking up the fact that it has been clicked on. Next, we need to determine the X and Y coordinates on the graphics control itself. We can do this by using a couple of Windows API calls. First of all is the getCursorPosition call. This takes a single parameter, which we're designating as the letter P. If we look at the beginning of this function, we will see that the local variable P is a point API user-defined type, which we're using to determine the mouse position on the graphics control. So the getCursorPosition call will populate our P variable. We can then use the screen-to-client call, passing it two parameters, the cblparam and the user-defined type P. This will give us the X and Y coordinates, which are two elements of that user-defined type. We can then determine the X and Y coordinates of the terrain by dividing the X and Y coordinates of the graphics control by the size of our terrain boxes. And we're passing these two values, the X and Y coordinates, to our dialog terrain info. This is a second dialog in our application. And as you will see, it takes the standard parent variable, which tells it which dialog called this dialog, and the X and Y coordinates we're bringing in. Having got the X and Y coordinates, we can determine who the owner of the terrain actually is by interrogating our owner map array. Having got the owner number, we can then interrogate the rulers array to work out whether that ruler is active or not. If it's returning a value of 1, then the owner is currently active. If the owner is 0, then this terrain currently has no owner. And we can populate the text box on screen to show those details. Plus, we're calling the countTerritories_owned function to determine how many territories that ruler actually controls. And we can then populate the controls on screen to pass this information back to our user. So while this provides some interesting information, however, there is more we can do with this pop-up window. I want to display two additional graphics controls. One giving us a display of the terrain from the main map, and one giving us a 3D look at the terrain. So let's have a look back at the dialog to see what we're going to add. First of all, we're going to add the two graphics controls to the list of objects on this second dialog. We're going to have a small graphics control and a larger 3D terrain one. We'll cover the code for the small map first of all. So in order to copy part of this first graphics control, I want to actually pick up the location, the X and Y coordinates that the user has actually clicked on. Now we're already picking them up in this PX and PY, so I want to pass them as additional parameters to the show dialog terrain info call. So there are our additional parameters, and passing the handle for the graphics control that we wish to copy, and the X and Y coordinates that the user has actually clicked on. So if we go to that function, we want to add those parameters onto the parameter list. And there they are on the list. So in order to accommodate these two new graphics controls, we'll need to make the dialog a little bit bigger. And there we are, taking our dialog up to 501 pixels wide and 350 pixels high. And we will additionally move some of the controls around to accommodate our two new controls. And we will add the two new graphics controls to the bottom of the code. This is for our graphics 3D terrain and for the small map. Additionally, I want to put something on the text to indicate to the user that the ruler for that particular territory is actually inside the territory, because this is used for calculation when we get to a battle routine. So we will slot a little if condition in there that tests the X and Y coordinates of the ruler. If they're actually matching the X and Y coordinates of the terrain the user has clicked on, then we can see that the owner is in the territory. So in order to copy a piece of the graphics control on the original payment dialog, we need to actually use a graphics attach command to specify that where we wanted to draw it to is going to be the new graphics control on the child dialog. So the graphics attach command specifies the small graphics map on our new dialog. We can then use the graphics get size command to pick up the X and Y sizes of our graphics control. On the small graphics control, we want to center the location the user clicked on in the center of the graphics control. So we're using an offset command to determine the top left-hand corner. We can then pass that to the graphics copy command. The graphics copy command takes a number of parameters. The first two parameters designate the handle of the payment dialog and the handle of the payment graphics control. And the values in brackets after that are the location onto which you want to place that data. And then we're using graphics redraw to redraw it to the screen so the user can actually see that. So we've also declared some new variables at the beginning of that function: the X and Y offsets and the X and Y sizes. So let's try running the application now. We can load our world map, process the first turn, and if we click on a location, we're getting our populated small graphics control showing the location that the user has actually clicked on. This is very useful as it saves having to move the dialog to see what's underneath. So now that we've achieved that, we want to display to the user a 3D polygon map. This will help differentiate between locations which are sea terrain and which are land terrain. This is a piece of code we wrote for a previous video, which we're just going to reuse in here. This piece of code is going to use the larger graphics control. So as we're using a different graphics control, we'll need to use another graphics attach command. So there's our graphics attach attaching to the larger graphics map. In order to improve the look of the graphics we're going to display, I'm going to use the graphics scale command. The graphics scale command allows you to set a custom scale for the X and Y coordinate system within your graphics control. In this case, we're making the top left-hand corner 0, 0, which is quite normal, and the bottom right-hand corner of the graphics control 680 by 580. And we're going to create a new function to draw the polygons on our terrain map, passing it the X and Y coordinates. So in order to use these polygons, there's a couple of user-defined types we need to set up at the beginning of our code. And here they are. So we have the first user-defined type set up as polypoint, which is taking X and Y elements, both singles. The poly array has count as the first element, which is a long, and it has one called X and Y, which is an array. And this is an array of polypoints. So we're going to have a polygon which has 4 sides, and each of the vertices of this 4-sided polygon will have an X and a Y coordinate. And the variables underneath this for the X and Y are going to be the size of our polygon map. So we're going to have 15 terrains left to right, and 15 terrains top to bottom. So we'll now create this new draw polygons terrain function. There's a fair bit of code in this function, which I will go through line by line so we can understand what it's attempting to do. First of all, we're passing the two parameters, the x and y coordinates, which are the coordinates of our terrain. And we obviously have a number of local variables. Variables of note, first of all, is the UDT polygon. This is set up as a polyarray, which is one of the types we created a moment ago. We're specifying the starting coordinates of this map to be 250 by 50. And the size is the size of each of the polygons. Remember, we're using a graphics scale here, so it will be scaled automatically for us by the graphics control. Next, we have to determine whether the graphic we're going to be displaying is 0 in height, i.e. sea level, or it's going to be terrain. The corners of each of the vertices are going to be one terrain. This allows us to show where the land is moving up from sea level or down to sea level. And our polygon count is going to be 4, as each of the polygons we're going to draw will have 4 corners. And then most of the rest of this is pure arithmetic, working out the x and y coordinates where each of the polygons is going to start, and the other 3 polygon corners. And finally, we're setting the colour of our polygon by designating either deep sky blue for sea or lime green for land. Using this method, we have 2 heights of each of the vertices of the polygon. It's either going to be considered to be 0 in height, or it's going to be 1 in height. This is where our vertical offset comes in. It will allow us in future code to actually have mountains, valleys, and flat land. So naturally, this is going through a for next loop looking at the height. So let's try running the application now and see what we get. We can load our world map, process the first turn, and we'll click on the Process Bulk Turns button to move the game on by 100 turns. This will allow our rulers to actually attain some territory, and we can then click to see what's happening. So there we have a ruler beside what looks like an inland sea. If we click on that now, we can see we have the small graphics map populated, and we have a 3D terrain map showing on the right hand side. This gives you a very clear indication of what the terrain looks like. At the moment, we only have either sea level or land. There are no mountains in this. If we click on another area, we can see quite easily a much better graphical representation from a 3D perspective of the land. What we will do in the next video is we will add further terrain with mountains, mountain ranges to our terrain map. However, that's it for today. Thank you for watching.